Good morning. So hopefully you're feeling okay about intersecting lines and simultaneous equations. If parts of that are still difficult for you, go over your notes, go over the homework, and let me know as well. Let me know where you're getting stuck, where you're losing the understanding of it, because it's really, really important. We're going to move on in coordinate geometry to parallel and perpendicular lines. Now in geometry, in normal geometry, you've already learned a bit about what these are. So we say that the line L is parallel. Here's our symbol for parallel, two lines down like this. The line L is parallel to the line M. The lines L are parallel to each other like this. L is parallel to M. That's how we read that. L is parallel to M if they never meet. If they never meet, they never intersect. So they never intersect. Well, what does that mean? The distance between them is always the same. Like train tracks. Let's sketch a quick example of what parallel lines might look like. So I've just got a little XY axis here, and I'm going to draw a line. I'm going to draw a line with a slope of 1, which means that every time I go up one box, I go over one box. Just to make it easy for myself to see it. I'll call that one the line L. Now if I want to draw a parallel line to this, the distance between them must be the same. And if the distance between them must stay the same, that means that every time I go up one here, I have to go over one. I have to have exactly the same steepness to this line, or I have to have the same slope. And we often draw on these little arrows to indicate that they're parallel. So as I was drawing that, I was talking about the important thing in coordinate geometry with these, which is that parallel lines have the same slope. They have exactly the same slopes. The same slopes. That is really, really important. Okay, so if you see a question where they talk about parallel lines, that means that you're going to be working with slopes. Something similar with perpendicular lines. So again, from geometry, what is our definition? We say that the lines L and M are perpendicular. So this upside down T symbol, L is perpendicular to M if they make a right angle where they intersect. A right angle, 90 degrees, a quarter circle where they intersect. So parallel lines never meet, and perpendicular lines meet at a right angle. Okay, what do they look like if we draw a picture of them? So again, I'm going to do a slope of 1, just because it makes it nice and easy to draw. So here's my line L. And if I want to draw a perpendicular line to L, it doesn't really matter where I put it, I'm going to do one going through here. And I'm going to make a right angle, and I actually know something about how this should turn out. But you can use your set square or the edge of the ruler to draw a perpendicular line making a 90-degree angle like this. Purple Pen's leaking. Okay, so M and L are perpendicular. What do we notice about the slopes here? I drew L, so it had a slope of 1. So it should be going through these boxes exactly. Okay, it should have been going through these boxes exactly. So my run is 1 and my rise is 1. My rise over run is 1. And if I look at my purple line down here, going in the opposite direction, but it also has a rise and run of 1, except it's going downhill, so it has a negative slope. So what does that mean? Well, it's hard to draw conclusions from just one example here, but I'm going to give you the fact about this. Perpendicular lines, when you multiply their slopes together, when you multiply the slopes of perpendicular lines, you will always get -1. Of perpendicular lines, you get -1. Always, always, always. And that's a fact. So what I like to say, and this is not the definition, but it helps us find the perpendicular slope, is that perpendicular slopes, perpendicular lines have opposite slopes to each other. Now, opposite isn't a mathematical term, it's just something I've made up. Opposite slopes. So we have to write down what we mean by that. And there are two things. We turn it upside down. I'm going to show you what I mean soon. Turn it upside down. And we change the sign. Okay, so for the moment, just take that as a fact. And I'm going to do an example that shows you what I mean by that. So we need an example. I'm going to write down the slopes of various different lines, and we're going to write down the slopes of the lines that are parallel and perpendicular to those lines. So example. Write down the slopes of the lines that are parallel and perpendicular to each of the following lines. So we'll give our lines labels: L, M, N, O, P, Q. That should be enough. So we're not actually going to write down the equations of the lines. We're just going to write down their slope. And then we're going to write down the parallel slope. And then we're going to write down the perpendicular slope. So let's look at this. So the slope of L, we're going to say, is 1/2. The slope of M is going to be 7/5. We can have top-heavy fractions like that. The slope of N is going to be 3. The slope of O is going to be -2. The slope of P is going to be -3/4. And the slope of Q is going to be -1. Okay, so the first step here, the parallel slope, it's super easy. It's exactly the same slope, a half, 7/5, 3, minus 2, minus 3/4, minus 1, because they have the same slope. So you just copy it down again. If that seems too easy, well, just think when you're in an exam and you've forgotten what parallel means, this is what we're testing, that you know the parallel slope means same slope. Perpendicular slope, though, I said it has to multiply to give me minus 1. So what will multiply by a half to give me minus 1? And I also said this is what we do. We turn it upside down and change the sign. We turn the slope upside down. What do I mean by that? The reciprocal. What do I get when I turn a half upside down? I get 2 over 1, and I change the sign. It was plus, so the perpendicular slope is minus 2. Does that multiply to give me minus 1? Well, is a half multiplied by minus 2 equal to minus 1? You can check it in your calculator, but it is. It is, because 2 by minus 1 is minus 2. Minus 2 over 2 is minus 1. So this one, turn it upside down. Instead of 7 over 5, I have 5 over 7, and change the sign. Put a minus in front of it. Now you can put that minus on the top one. Remember I said that I usually do that. Do they multiply to give me minus 1? 7 over 5 minus 5 over 7. Look what happens. I get minus 35 over 35, and that is minus 1. So that's why it works, because you end up with the same number on top, same number on bottom, but a minus. So that is minus 1. This one, 3. How do I turn 3 upside down? Well, this is really 3 over 1. So to turn it upside down, I get 1/3. Change the sign, it's minus. Is 3 by minus 1/3 equal to minus 1? It is, of course. Minus 2, turn it upside down, and it becomes minus 1/2, but change the sign and it's plus. So this one is plus. And is a minus 2 by a plus 1/2 equal to minus 1? Well, it's the same calculation as up here, so yes, it is. Minus 3/4, so it's going to be plus 4 over 3. You can write down the plus if you want to. Minus 3/4 by plus 4/3 is minus 12 over plus 12. It's minus 1. And finally, this one. This one's a bit tricky, because what is this? This is minus 1 over 1. So when I turn it upside down, I get 1 over 1, and change the sign to get plus. So it's plus 1. That's the one that catches people out a little bit. Is a minus 1 by a plus 1 equal to minus 1? It is. So there we go. That's our parallel and perpendicular slopes. Okay, so how do we get the slope from the line, though? Okay, so this is great if they tell us the slope, but how do we get the slope from the line? Well, I'm going to do it in a separate video, because this will give you a chance to maybe do it in the second class. Thank you.